Okay. Welcome everybody to the Simon Says TinkerCAD workshop hosted by IEEE UTD Tech Committee. So first off, I would like if all of y'all would sign in for those of you here. I'll leave this up for a second and later on during the stream, the link will get posted if just in case whoever joins in late. Okay, so for today, we're going to be using TinkerCAD, and this is just an online simulation tool for 3D modeling, circuit design, and coding. We use we use the circuit design most here, and it's been useful for our online tech workshops. So first, y'all are gonna have to create a TinkerCAD work account. So you'll have to go to tinkercad.com, click join now, create your personal account, and then sign in with whatever email y'all want to use. Then once y'all are signed in, you have to go to the left column, click on circuits, create a new circuit, and then you'll be ready to start this workshop. I'll give y'all a couple minutes to do this. Okay, so basically the basics of an Arduino is it's a credit card sized microcontroller and it's very versatile, powerful, and it's also low priced. And there's a lot of people who use it, hobbyists, makers, students, and especially engineering students. So the parts we'll be using today is an Arduino, some push buttons, some resistors, and some LEDs on top of it. So the wiring for this workshop is very simple. It's going to be very coding heavy. And we're going to demo this workshop now. And I would like to thank you all for joining me and sign in if you haven't already. So first off, we're going to need an Arduino Uno. And next few components we're going to need are um, 4 LEDs. We'll also need 9 resistors. We will need a breadboard. We will need 5 push buttons. And now we just have to wire everything up. So to start off this project, I am going to set the I'm going to set the LEDs into the breadboard. After that, I'm going to put the push buttons onto the breadboard as well. And I'm going to set them in the middle so it splits in between this little bridge right here on the breadboard. And lastly, we have to put the resistors before we wire them directly to the Arduino. So for the resistors, you're going to put them on the bottom left pin of the push button and connect it to this plus sign right here in this column. And we're going to supply power to here and then ground over here. So let's do that now. So we're going to connect power here so we can power the push buttons and then also give it ground. And we'll make these wires black and red. So for all of these, we're going to connect the bottom left pin to power. And for the LEDs, what we're going to do is on the anode side, we're going to put the resistor in series. So we're going to have to rotate it and connect the resistor on that side, on the anode side of the LED. And we're going to do that for each LED. Now, everything else we're going to be doing for the wiring will be using the Arduino. So what we have to do for the push buttons is we have to connect the bottom right pin, terminal 2A, to ground. And we will make these wires black so we know that it's ground. And we're doing this just so power can get in and out of the push buttons. And next, for the push buttons, we are going to connect some wires so we know when the button has been pushed, and we're going to connect them to the analog pins. So we're going to connect it in right next to the resistor for each one of these. And I'll be using pins A0, A1, A2, A3, and A4. Well, actually up to A3, my bad. Wait, no, A4 because we have 5. So we're going to be wiring all of them. I'll change the color of some of these wires so it's easier to tell which one goes where. Well, make this orange, this one yellow, this one purple, and this one pink. So now all we have to wire is the LEDs, and what we're going to do for that is we're going to connect a wire right here next to the resistors that are connected to the LEDs. I will be using pins 2, 3, 4, and 5 for this. And essentially what we're going to do is these LEDs will light up based on NR codes to tell them to turn on, basically. And that's all the wiring for this, essentially. And now we're going to head into the code. So we're going to be coding in text. And first off, we have to declare some variables that we're going to be using. So first, we need to know the pins of the LEDs. So I'm going to use an array and put in the pins I used for the LEDs, which are 2, 3, 4, and 5. Next, I'm going to declare a constant integer called max level. And I'm going to set that equal to 100. So there will be 100 levels in this, and you can change it however many times you want. You can change this to 100, 1,000, 10,000, whatever you want. And next, we are going to need an array that will hold our sequence, and it will only be able to hold the maximum level number of sequences. And we will need another array called your sequence, and that will hold the sequence that we put in using the push buttons. Next, we will need a variable to know what level we're on, a variable to know our score, and lastly, a variable for how quickly we want the game to go. And now in the void setup, we're going to tell the Arduino that all of the push buttons are inputs. So how we do that is we do pin mode, and we connected all of the push buttons in the pins A0 through A4. So we're going to do A0, comma, input in all capitals. And we're going to do that for every button. So pin mode A0 input, pin mode A1 input, and we're going to do that all the way until we hit A4. Next, we have to initialize all of the LED pins to set them as outputs. I stored all of my LED pins here in this array, so I'm just going to use a for loop to initialize them. And I'm going to do this by using a counter, which is going to be I. And I will do pin mode, LED pins, I, and it'll go from index 0 through index 3 and say that each of these are outputs. And that's all we're going to do in the void setup. Next is the code we're going to be repeating in void loop. So in the void loop, we first need to generate our sequence, and I'm going to be writing the code in functions. So if the level is still equal to 1, that means we have not started the game yet, and we need to generate a sequence. I will name that function generate sequence. And otherwise, I'll do if, and I'm going to do a digital read on A4, and that is connected to this push button right here. So once this button is pushed, it means we're going to start this game, the Simon Says game, and this is basically just a power button. So if this is equal to low, meaning it is not pushed, or level is not equal to 1, meaning we have started the game already, we are going to start showing the sequence we generated. And we're going to do that with show sequence. A show sequence function we're going to write, and we will write a get sequence function, which is the sequence we put in. So that's all we're writing in the void loop. The rest will be written in our own little functions. So the first function we're going to write is show sequence, actually. So this function will be a void function because it won't be returning anything. It's just going to be showing the sequence we generated. And in this sequence, or in this function, we need to show the sequence we generated. So we're going to first turn off all of the LEDs to make sure our sequence isn't being interrupted, or there isn't an LED left on from a previous sequence. So how we're going to do this is we're going to go through each LED and turn them off. And we're going to do the same concept here as a for loop, except we're just going to turn them all off. So we're going to do a digital write for all the LED pins in the array. And we're going to make it low, meaning they're turned off. Next, we will do another for loop, and This loop, what it's going to do is it will turn on a LED based on the sequence we have generated, and it will turn that specific LED on. So we will do a digital write sequence high. Then we will delay by the velocity that we determined at the start of the game. And that just means it'll go slow for now, and then as the game progresses and we go to higher levels, the delay will be smaller and smaller, making the game more difficult. And after that, we will turn the LED back off. And we'll do that by doing a digital write and turn it off again using low. Then after that, we will do a delay of 200 milliseconds. Next, we are going to create our getSequence function. And that will be a void function because it's not returning anything also. We're just generating a sequence. So first, we're going to create a flag, and we will set that equal to 0. So essentially, this will indicate if the sequence is correct or not. So first off, we'll do a for loop. And it will be for as long as I is less than the level. So we will set the flag equal to 0 again, and we will do a while loop that while the flag is still equal to 0, we are going to check each of the buttons and see if they've been pushed or not. So it's going to be if the first button right here has not been pushed, which is A0. So if that button is low, then we'll do a digital write and turn that LED on because it is corresponding to actually it'll be 2 right here because the corresponding wire to this button or to the LED is connected to pin 2. So we're going to turn this specific LED on, and we will input that our sequence we pushed that this LED right here turned on, the leftmost LED, and we're going to store that. Oh, this is the function for retrieving our sequence, not generating it. My bad. So yeah, and then we will do flag is equal to 1 because we found where we pushed the button. Afterwards, we are going to do a delay of 200 milliseconds. And we're going to test if our sequence matches the sequence that was generated. If it wasn't, we submitted a wrong sequence. Otherwise, we got the right sequence. So if our sequence does not equal the sequence that was generated, then we submitted a wrong sequence. And that will be a separate function also. And if that is done, we're going to hop out of this function. Next, we are just going to copy and paste this, and we're just testing if the following buttons have been pushed. So you can just copy this code, create some white space, and then paste it. The only things we're going to change is the button pin specifically. So the next button down is connected to analog 1 pin, so A1. So we're going to change A0 to A1 to see if it's pushed down. The LED that's connected to that specific pin is connected to pin 3, as you can see right here. Then this will get changed to 3 also, because the pin that we pushed down was 3. We will say the flag is 1 because we found the button that we pushed, and the rest is the same. And we're going to repeat this 2 more times to for the remainder 2 buttons that are connected to LEDs. So that will be done for A2. This will change to 4. This will change to 4, and the rest stays the same. The last one is for the 4th button down, and that is connected to pin A3. And the LED is connected to pin 5. And if it goes through all of that and no wrong sequence is entered, we are going to call for the write sequence function, which we will write further on in the code also. The next function we're going to write is the generate function. And what this does, it's going to fill our sequence array with the sequence that we want to imitate. And it will turn the specific LEDs on. So how we're going to do this is we're going to use a random number generator function. So how we do that is a random seeds function, or random seed, and we will type millis inside of it, which is another function. And what that does, it generates a random number. And now what we do is we create, we will use a for loop to fill up our sequence, and we'll use the counter I up until we reach max levels. And what we will do is we will store that sequence, or the number generated, into our sequence. So we will do random 2 through 6, because our pins are connected to pins 2, 3, 4, and 5, and the 6 right here isn't included. So it will use the numbers 2 through 5. And that's all the generate sequence function is. The next one we're going to write is the wrong sequence function. So in the wrong sequence function, we are going to flash all of the LEDs on to indicate that you did not put in the right function or the right sequence, and then we're going to turn them all off. And then after that, you will have lost the game, and we're going to reset the level to 1, the score to 0, and reset the velocity back to what it originally was. So to flash all the LEDs on, we're going to flash all of the LEDs on 3 times. So this will be used to turn the LEDs on 3 times, and then the 2 for loops inside of it will turn the LEDs on and turn them back off. So we will use this for loop to turn all the LEDs on. And we'll do that using a digital write, use the LED pins, and turn them on with high. And next, we will delay for 250 milliseconds, and then we will turn the LEDs back off. We will do a digital write to turn them back off and go through all of the LED pins again. And after that, we will do another delay so you could see that they're turning off. So that's all it is for the for loop. Now we need to reset the rest of the things we said. So we will set the level back to 1, the score back to 0, and we will set the velocity back to 1,000. So that is the wrong sequence function, and next is the right sequence function. So in the right sequence function, what we're going to do is we'll turn all the LEDs low. We're going to turn them all off. We'll turn them all high only once to indicate that we've done it right. And then we'll turn them all back off again. And then we'll increase the level and lower the velocity to increase the difficulty. So it's kind of just our level up function. So first, we turn off all of the LEDs. And we do that with a digital write. Go through all of the LED pins we have stored in the array and write low to turn them off. Next, we will write for loop again, and all we're going to do is change low to high this time to turn the LEDs back on. And lastly, we will turn the LEDs back off so you can see that they were flashed. Oh, first we have to put a delay in between these. Otherwise, you won't see that they were turned on and off. It will just do it really quickly to the point where we can't see. So we'll turn these LEDs back off. And we will do that by changing the digital write from high to low. After that is done, we will do another delay for 500 milliseconds or half a second. And for as long as the current level we are on is less than the maximum level we set out, we are going to increment the current level we're on, and afterwards we will decrease the velocity by 50, which will increase the speed of the game. And that's all of the code for this. We can now test it by starting a simulation. Looks like we have some bugs in our code. Let's see where they are. Let's see. It's saying it was expecting a semicolon. Oh, I didn't declare my functions, so I have to do my function prototypes. Basically what I'm doing here is I'm telling the microcontroller that these are functions I'm going to use, and I have to declare them before I call them. So that's essentially what I'm doing. And what were the last two? Wrong sequence and correct sequence. And right sequence. Let's see. So it should be max level, not max levels. What else? Now it's just saying it's expecting a semicolon before a specific thing. I apologize. While I try to find this one semicolon I forgot to put somewhere. Oh. Okay. So I just put one too many parentheses, and that was the problem. So now I will demo this workshop for you. So I'll start the simulation. And as you can see, nothing's going on because I haven't started the game yet. So after I push this button, the game starts. And all I have to do now is try to copy the sequence. And it's essentially just a memory game. So it will turn the LED on based on what shows up, and I just try to copy it. And that's all there is for this workshop. And as you see, if I click the wrong sequence, the LEDs flash 3 times and the game turns off. So once the game turns off, I can restart the game by pressing this button again, and I can play as long as I want. Yep. And that's all there is to it. So if there's any questions, y'all can drop them in the chat and I can try to answer them. No problem for the demonstration. And if there isn't any questions that y'all have, y'all are free to go now. I've finished the workshop and this will be uploaded to our YouTube. If y'all want to come back and visit it, feel free to mess around with the code and see how y'all can make the game more fun, make it go faster, make it go slower, increase the number of levels, whatever you want to do. Otherwise, that's all I have for y'all tonight, and I hope y'all have a good rest of your night.